Okay, hello. Um, this is to Helen back, going rogue in Unreal. I'm gonna start with a little intro. My name is Alissa Vovers. I'm from Summerfall Studios, based in Melbourne. I'm an engineer. I've been there for a few years. I was a programmer on our first game, Stray Gods, the role-playing musical. I ran engineering for our DLC, Orpheus. And I'm still there working on our next game. If people were paying attention in the speaker notes, maybe you noticed that I was not initially listed to be the speaker for this talk. That was our engineering director, Troy Ferguson. Sadly, he couldn't be with us today. Yeah. Yeah. He had to stay behind to handle the last boatload of work to hit our major milestone today of going into early access for our next game, Malice. Thank you. So, Malice is an unholy roguelike deck builder where you play as Noah, a former priest turned exorcist and demon hunter. Choose your path carefully through a demon-filled city, forge precarious alliances, and strengthen your deck of arcane tricks. Marketing done. What is it? It is, like Stray Gods, it's another kind of weird thing to do in Unreal. It is a fully 2D game done almost entirely in UMG. We started the project back in August last year. We had our first prototype by September. We hit alpha at the end of October, and we're at 10 months of development now with getting into early access. So this talk is a not quite post-mortem, but we wanted to let you know some of the successes and struggles we went through, the features that we made to make a complicated game with many moving parts in a short amount of time. So let's start with how we handled data. If you caught Zhikeng Xiao's talk yesterday on the gameplay ability system, you're up to speed. But if you missed it, here's some basics. The GAS is an out-of-the-box Unreal solution for implementing attributes and abilities that an actor can own or trigger. There's a lot to GAS, more than I can explain in a particular talk. These are the main big three aspects of it. You have your gameplay abilities. These are things that can be activated or triggered, like casting a spell, doing a dodge roll, stuff like that. Attribute sets define attributes that represent resources for your actor. These are things like health or stamina, and they drive calculations throughout GAS. Gameplay effects can be used to mostly modify actors. This is usually the result of a gameplay ability. A lot of the time, these are used to update values of attributes, and they are applied temporarily. These are things like status effects, so slow, which reduces your player or your enemy movement speed. GAS is primarily designed for action RPGs, and we made a card game. So surely that's not right, but we thought that initially, and then as we were moving through our design process, we realized we could leverage more and more of the system. So how did it end up working? Each of our cards is a gameplay ability. We have a common base class that defines a bunch of functionality that we then use to create many abilities quickly and efficiently. Our cards use gameplay ability target actors to pick the target of our card, and then each of our entities, like the player, the demon, the host, other things in the exorcism, all have an attribute set that gives them explicit stats like will for your health or ward, which is like block, as well as hidden ones like damage modifiers. We set up a gameplay effect calculation. Whoops, that's too fast. Nope. Oh my God. That's fine. I can do that. We set up the gameplay effect calculations that take raw damage values and then apply modifiers to it, and then split it across targets like ward and will. And finally, we have a bunch of gameplay effects on the cards that make all of the wheels of GAS turn. So I'm not going to lie, GAS can seem heavy, but a lot of the time, if you need one bit of it, you probably need a lot more of it. And it can take some time to learn, but it's probably less than it would take you to develop your own framework. And once learned, that knowledge is easily transferable to other projects. We started using it while working on an action RPG prototype and used the learnings from that to move them over to Malice. So just getting over that learning curve is useful and very, very helpful for future projects. Things to be aware of, it does not handle turns. Our biggest issue with Gas was actually caused by because it's designed for action RPGs. So out of the box, it handles things like effects with duration in terms of seconds, and we needed them to be handled in turns with a variable playtime length. So since there's no limit on how long a player can take per turn, it was a serious issue. We couldn't have players waiting around until an effect was expired before playing their turn or having that effect last longer than it should. When we were looking into it, there were some workarounds that people have found to modify your engine level native changes, but instead we built an intermediary layer that replaces the duration timer with a subclass that we essentially were like, it is 0 until we manually tell it that it is 1, and then it is done and it can go on to the next turn and can't end all those effects. The other thing is that it does not serialize nicely. Its attribute sets can be saved and loaded, but depending on your setup, that can be tricky. But gameplay effects are mostly temporary. It wasn't a huge factor for us because we just don't save during our exorcisms where most of our abilities get triggered. But if you wanted to try and do it, you would have to save out your attributes, save your effects for all your actors on what at the particular time when you're saving, and then when you reload all those attributes with the remaining time of each of the effects on that actor, and then apply them accordingly to essentially reapply all those effects to the actors. It's a little bit tricky, but it'll work. For our visuals, we used the model view controller pattern, or MVC. It's an architectural design pattern where certain concerns are separated out into categories. To simplify, the model is the data and the logic of the game. The view is what the player sees. The controller is the intermediary connection between the two systems. This is things like handling user input and updating visuals and triggering manipulations in the model. If you're a software purist, what we ended up doing isn't exactly MVC, but it gets us where we need to be. The model is our gameplay data, our cards, our enemies, the players, and all the back-end logic. The view is pretty much exclusively UMG. It's our exorcism widget. It's like shops, it's things like that. The controller is the player controller, but it's also a custom messaging system that I'll get into a little bit later. So why would you want to use this? It decouples things, reducing their dependencies. It allowed our engineering and our UI UX teams to work independently at relative ease. You can essentially hot swap your loadout. And we were able to change our MVP UI full of terrible programmer art with our proper UI with little effort. And we don't have to worry about breaking other people's work because they're completely separated. It also makes it easy to experiment with the model or the view and not have them not risk breaking anything within that. Some issues, it is a layer of abstraction. Every layer increases flexibility, but that makes it harder to intuitively understand. There are more moving parts, and that increases complexity. Decoupling means the model had no concept about timing, which was an issue for UI, especially for things like VFX. So to ease communication with the controller, we wanted a flexible way to communicate events that the controller could react to. So we built the message bus system that I mentioned earlier. This message bus allows communications between systems by sending and receiving messages. We picked this up from James Tan's talk last year at Unreal Fest Gold Coast, and I've been told that if you dig into Lyra, there's a version of that in there as well. But the message bus essentially defines the kind of payload you want to pass on to a listener through delegate functions. When a sender wants to notify you that an event has occurred, it passes the message to the appropriate message bus, which then broadcasts that event out, and any listeners bound to that function will receive the message. So let's have a little example. This is an exorcism. We've got gas and all the stuff that's running under the hood. This is essentially our combat. When the player plays a card successfully by picking a valid target, in this case the demon, it uses the exorcism message bus to call the function card play completed with a particular payload. In this case, it's the player, the one who played the card, and the card that they played. The exorcism message bus then broadcasts that out, and both the exorcism model and the UI are listening to it. So the model handles the back-end mechanics based on that payload, getting any damage modifiers and affecting the demon's will, reducing any resources that the player has, while the UI updates the visuals. But message buses can be used for anything. We have message buses for narrative purposes, for our random loot generation, or triggering our economy. So they're quite helpful. But why would you use them? Reducing more dependencies. If you want to subscribe to an event, you can just grab the appropriate bus and away you go. You don't need to remember which class is responsible for what event. It's all there in one place, which reduces the cognitive load of using the system. This also makes it easy to maintain. It's super simple for anyone to add a listener to an event. You don't need to track them down or pass around instances of objects everywhere just to access their delegates. This also leads to reduced coupling because classes just need a reference to the message bus to send or receive messages. So you can decrease your class dependencies, which allows the system to accept changes more readily. If you work with UI, you use delegates all the time with your on hovers and your on clicks and things like that. And we just made this message bus system to help facilitate communication across the project as a whole. Considerations. Anything can listen for anything. This is good, but it is also very bad. It can make it hard to read or debug code because there's not a direct line between a caller and the callee like there is with a regular function call. It also means that if you change something in the model and something is listening to it, you might not get the reaction you expect if that thing is no longer broadcasting. When you take all the events for the game and put them in a single bus, they can become unwieldy. Just one message bus can grow to contain dozens of functions, though they're mostly boilerplate, so the class itself isn't complex. You can mitigate some of this by breaking out the message buses into logical sets like you would for any other class. So we had 4 to 5 message buses for our shops and our exorcisms and other things. But when you do that, you start to lose the benefit of consolidating them because then you have to connect to that particular message bus. So now everything is communicating swiftly, but a little bit too swiftly. The separation of the model and the view means that the model is updating immediately, but the visuals need to be slower while the gameplay remains responsive, which led us to making the action queue system. So what's an action? It's anything we want it to be. It can be a visual thing. It can be a gameplay event. It's a queue. It's nice. It's orderly. It's first in, first out. It allows us to stack multiple actions, one after the other, handling timing and the responsiveness of play. Each action in the queue executes when it reaches the front of the queue and is responsible for alerting the queue when it's finished, handling its own timing. So this is just a little example of a queue. When a card plays to damage the demon, damage in the VFX gets added to the queue. The first action in the queue plays, then it removes itself, then the entire queue moves up, and so on. Under the hood, the model is still updating immediately, but the action queue allows us to display the consequences of the action to the player with our design-specified timing. While all this is happening, the player still has control and can keep playing cards. So let's rewind a little bit. You played a card, things are happening in the action queue. You play another card, more things get added to the action queue. Your damage, your VFX, this time a status effect. They all go in. Things move out. It keeps going. Everything happens at the same time, and it behaves exactly the same. It allows us to have this responsive play while still giving good player feedback. And We have queued actions for things like our player death or the demon's death or special exorcism events. Ending your turn gets added to the queue with a series of other actions inside of it that then trigger. It's very helpful. And they're also easy to make. By building this thing, we allowed our VFX teams and our SFX teams to be able to create their own actions pretty easily and add them to the queue. And that lets them put the tools in the hands of the people that need them. They're also very easy to change, either natively or in Blueprint, without the intervention of an engineer. And all of the actions' timing can be adjusted on the fly. All of the action queue stuff combined with the message buses means that other teams don't have to wait for engineering to implement the things that they need, and we don't have to do extra work. But why? That's what they look like. They're just that. And they can be anywhere and they can do anything. And they don't have to tie into gas because they don't need an actor. So that's the other benefit. Major downside. Debugging issues is harder because the function that queued the action is finished before the action executes. We lose some context, like not having access to the call stack. When things go wrong, it can take longer to track down when or where an action is coming from. And there are a lot of actions that play out over the course of an exorcism, meaning there's a bunch of memory allocations that are happening in the background, and that could impact performance at a higher scale. This can be mitigated through things like pooling or other like caching techniques, but that is an additional effect that if you want to use this kind of system, you'll have to account for. To mitigate the problems of the loss of context, we need to follow the flow of interaction. So we wanted to do some custom logging to be able to track down things. Logging is an incredibly valuable tool for debugging and is sometimes seen as a less powerful tool in the engineer's toolbox, but it's still very useful. For instance, it's probably tough to ask a player to remotely attach a debugger to their machine. So what can we do? Most folks are going to be familiar with your basic Unreal logging. You have your standard logging, your more old school printf style positional arguments with type specifiers, hello world. And as of 5.2, you have structured logging. This is a little bit more modern with positional arguments that can make things a little easier to read and maintain more complex logs. Both of these take a log category, your log temp or your log core, or you can make a custom one if you'd like, and a verbosity level, your log, your warning, your errors. You can use these to filter logs either before they appear, so they don't show up at all, or afterwards if you want to find something in particular. It's very helpful. We took at Malice and identified a number of streams of data that we wanted to track. Firstly, we wanted a detailed log of the game to help track down issues and record player decisions. This was primarily for things like the action queue that get very messy and were harder to debug. But it was also helpful to see how players were playing the game. We could collect these detailed logs after they played, rather than having to like hover over their shoulder or watch like a recording to gain insight into their particular play style and what worked. On top of that, we wanted to perform broad analytics to help aid in balancing the game and card play by tracking how often cards were picked as rewards, what cards were in what index that successfully finished runs, did you actually make it through, things like that. Lastly, when a player's run ended, we wanted to show the player how their run went and let them reflect on it, perhaps gain a little understanding of what went wrong and what they can do better for the next time. Once we figured out all that out, we knew that we had overlap between events from each of the use cases. We wanted to find a way to not put a group of 3 log statements all over the place just to get the different kinds of data we wanted. Whatever solution was needed to be extensible. If we found more use cases, we didn't want to have to waste time backtracking through all of our code to add new logging everywhere. Most importantly, we wanted to log data and not text. We wanted to be able to use the data to do some complex analysis after the fact. And if we use straight text, we would need to write a tool to parse it, which, considering we were trying to save time, sounded like a bad idea. Specifically because of this last point, we didn't want to use Unreal's built-in logging, at least not for the whole solution. So we designed our own system to suit our needs. These were the main three pieces. We built a logging subsystem to manage the lifetime of our different streams, to be easily accessible and to function as a unified interface. This is the only part of the solution that is exposed to the user. The rest is internal. So to handle the different streams of data, we made a channel class. When the subsystem is used to log an event, it gets forwarded to each channel and then stored until it gets written to its target. The target is where most of that magic happens. It's responsible for taking the events that have been logged into the channel and transforming them from that payload data to whatever shape we needed for the channel's purpose. For example, our analytics target can take an event, convert it into whatever format is required by our analytics platform, and then send it off via a web request. Separating this behavior into its own object gives us a lot of flexibility. It's very easy to reuse them or to swap them out. So we now have a system that can easily adapt to changes in our needs. We can scale it up if we need to make more channels, and we can change how each channel processes data by updating its target. And we can make new targets pretty easily. Unfortunately, there's no such thing as a free lunch, so what did ours cost? It's more complicated. Setting up the channels, writing new targets, retrieving the subsystem are all points of friction. Parameterization of the event itself is messy. There are a number of ways that you could go about it, through polymorphism or instance structs or some other things, but we ended up, they're all a little bit messy. We ended up just using a flat struct that has a lot of redundant fields to get the broad coverage we need for each of the different targets, because that was the quickest and easiest way. This also has some potential performance issues at larger scales because you're dealing with pointer indirection, virtual calls, lots of branching, and that are things that can impact CPU performance at a higher scale. It wasn't an issue for us because all of our stuff is a little bit smaller, but your needs might be different, so it's worth mentioning. So now that we've got this detailed player log, we can skim through every choice that the player has made throughout the game. But in a roguelite, there's a lot of randomness inherently, and every time you play is different. So with that randomness, even if we step through, how can we replicate their experience? So let's talk about random number generation. Firstly, a little rundown on pseudo-randomness, which is what randomness is for computers. It's a sequence of numbers that approximates randomness using a starting seed value. If you use the same seed when generating, you get the same sequence, making randomness deterministic and predictable. The next time you ask for a random number, it pulls out the next value in the sequence, just moving down that list. For most games, you want an unpredictable seed to start the game so that every time you play, it plays out a little bit differently. And thankfully, Unreal handles the seeding of this with something like time, so you don't have to think about it. We all kind of know standard random functions. It does all that work for you, so you don't have to think about it. And for a lot of the games, this sort of thing, like using standard random functions, is perfectly adequate. But if you wanted a little bit more control, you can do this using Unreal's second method for generating random numbers, random streams. This is a variable that can be used for random generation, just like the standard functions, but it gives you control over the seed value. This means that when you encounter an issue, you can save the seed and replay the game using it to get the same series of random numbers. And because they're variables, you can do things like having different random streams for different features, or like the types of rewards that you get from a win can be completely separated from the way a map generates. So, benefits. Maybe you want your different actions to influence randomness differently. You can have concurrent random streams, like I said before, and it's helpful to prevent with minor issues of randomness. Things like having your random VFX muzzle flashes affecting the type of loot that drops. You don't really want that kind of stuff to happen. If you want to support replays, you have to have minor changes but you want to have minor changes within that, you can use the random stream variable to do the major randomness across it and then have another stream that handles all the small things so that when you replay a game, there's minor changes throughout, but you're still getting the same play. You might have a harder time debugging a game that has randomness, which is one of our issues, because things are not happening in the same order if they're getting a random seed every time. The last one was a big motivator for us because most of our mechanics use RNG to some degree, which encounters show up, what cards you draw, what rewards you're offered. So tracking down the issues with things that are like triggered with initially from randomness was a concern for us. There are some gotchas you should be aware of. They are variables, but you need to be able to access them somehow. And we used a subsystem, and you could use something similar to make the access of this random stream easier, but that'll depend on your use case. If you pass the random streams around in your functions, it's important to remember that random streams are structs, and they will follow copy semantics. So make sure you pass them around as references, otherwise you will not be using the same random stream. You will also forget to use them, and you will use the random standard functions instead, and you will get caught wondering why your RNG isn't deterministic. The last problem was our most common issue. The muscle memory just means that we tended to automatically use the standard RNG, which was causing a lot of subtle bugs. So something was like looking and feeling random, but then when we hit a bug and we tried to replicate the thing, we couldn't. You just get a different result. So you can build a validator to check whether or not your random streams are whether you're actually using random streams or whether you're using your standard functions on your save to try and prevent this issue. So between the use of the random streams and the detailed player logs, we can accurately replicate a player's experience, making balancing and debugging a lot easier. So I went way too fast, but that was a rundown of some of the systems we made to get Malice up and running. So this to recap, we used GAS, gameplay ability system. We had our pattern, the MVC, model view controller. I believe Jack Condon has talked about, Jack and Adrian Pugh has talked about similar patterns for the model view model system. Adrian's going to be talking about UI, quick UI prototyping after this, which will be very useful for people who are trying to get that prototype and have that easy swap between your features. Message bus was very useful. The action queue was also useful. And I now know that you can do a little bit more with GAS. So then you can do some of the things that we used for the action queue with GAS. But because of the way that, because GAS it was only applied to actors, the action queue was still very useful for us. Custom logging is very helpful, and the random streams was necessary. So yeah. These are the systems, the inbuilt Unreal systems and the custom systems that we use to get our game going. It's flexible and complicated, but we got it working. A few times we came close to digging ourselves into abstraction hell, but it works. So some final thoughts. These were some of the areas that we spent time fortifying and working on and making adaptable. When you're short on time, having to go back and change a system can be brutal, especially if you need to update any work downstream of that system as well. Adding layers of extraction tends to make your game more robust and insulate them against change, but you need to remember that there's no such thing as a zero-cost abstraction, and be sure to weigh the pros and cons of each before diving in. Leveraging systems in creative ways can help people speed up development, so don't be afraid to mess around with existing systems. And with all this, Malice is here. It is now in early access on Steam as of 2 hours ago. So you can check it out, see what we've done and the systems. If anything feels like it'll work for you, let me know. And yeah. Malice. Anyway, I guess there's question time. Yeah.
Thank you. Hello, thanks for the presentation. I was very curious. You mentioned this action queue where the player can queue up like the next card after while the current one is playing out. It's animation, and I know this in general. This feels great, but I was wondering, like, how do you prevent the player from doing actions that are currently already in effect? Like how not to mess up while this because they're seeing basically an outdated view of the world, right? The view is still catching up.
The action queue just we've separated out some of the interactions that use the action queue from other ones. So like the way that we're doing like our card movement and the interaction doesn't use the action queue. So there's particular events that will go into the action queue system and others that don't, so that we can have that like responsiveness and things like that. But then if like the player pauses the game during it, it's just gonna stop. So then we don't have to like we don't have issues with the action queue like trying to speed up or like go in the background of something else happening or getting interrupted. Yeah.
Thanks.
Hi, I just had a little question about the RNG section. You mentioned that in some of the whys, you're controlling, with the random streams, you're controlling what changes randomness. The second point was something about replayability and how you might change randomness a little bit. Maybe I didn't fully understand what the benefit was in that one. Do you mind just? Yeah.
Yeah, fair.
Thank you.
So for that one, it's things like if you want to replay a seed, like if you want your player to be able to put in like in Balatro, right? You can put in whatever seed you want and like go through. And when you go through from there, you'll have your it'll still play out in the same way if you play in the same way. But if you wanted to have other things, like other effects that look different, so that you're separating out like the interactions that you want to be deterministic versus the ones that you want to still be random. So like that would mostly be things with visual effects that you don't want the player to like have that the randomness of like the intended interaction so that the player can get that same experience if that's what they want, versus the like other little elements of randomness that you might want to have like different visual things spawn in your world in certain points that are more aesthetic and less intentional for gameplay. Yeah.
I was wondering, you mentioned that gas doesn't serialize, so saving mid-turn was kind of an issue there. Does that action queue that you developed, is that sort of your solve as well for that issue?
Our solve for the serialization for gas was to not save. So we basically like have it so that when you go into an exorcism and you quit or something like that, it just takes you back to before. So we use like the traditional checkpoint style gameplay saving. Yeah. Okay. I think, oh wait.
Hi again. I was wondering, since you implemented gas in a turn-based game now, like, did you have to modify the engine in order to make this work?
No. So we didn't modify the engine. We added in a extra subclass for the timer, so that instead of using the default timer duration and like waiting for the seconds to tick, we had it like stay at 0, and then when the player like pushed end turn or something happened to interrupt the turn, we would then send a call being like, you've reached whatever desired duration it is. And then the next time that the gas was ticking, it would then trigger and be like success, and then end whatever effect is necessary. Yeah.
All right, sweet. That's pretty good.
Yeah.
Thank you. Hey, I was just curious about the VFX layer of things. Since it's all UMG based, are all VFX like image based or material based, or is it like a Niagara abstraction?
They're mostly material based. We use, I think, a bit of Niagara, and a lot of material based definitions and yeah, shaders and stuff. Yeah.
Thank you.
There's more. We've got time.
Okay.
Thanks. I was just wondering, do you ever like fake randomness to make it feel more fair?
No, we don't fake the randomness. We will change the like design around it. So like the way a mechanic works to make something like feel a little easier than what it actually is. But we don't, I wouldn't say we don't fake randomness specifically. There are a few cases where we will override whatever the random thing comes out, like things in the city map, for example, like when we have the map generation, we will, by default, it will randomize every like encounter that you get in map, and we just go in and we override over particular ones or prevent it from picking particular things and getting like the randomness, letting it pick randomly, but until it gets to one that is like not the one that we want, or like something that is the one that we want, like an exclusionary list, essentially. Yeah.
Yeah. Cool. Thank you.
I think we've got time for one more.
Okay.
Hello. Is there any specific reason that you guys didn't use the gameplay message subsystem, or was it like you made the message bus and then, oh, there's this system?
Pretty much. Yeah, I mean, the message was we wanted a little bit more control in general. So like, Troy really loves to build his own systems and loves to have control over those systems and the specifics of what they do. And it wasn't quite like yes, pretty much. And what Unreal's system for that was just not quite like what we wanted. Yeah.
Fair enough. All right. Thank you.
Yeah. Okay. Thank you.